Welcome to the experiment on refrigeration cycle. In this experiment, the working principle of a vapor compression based refrigerator will be investigated using a laboratory unit. A refrigeration cycle consists of four main components that execute four main processes of a refrigerator. These components are compressor, condenser, an expansion valve, and an evaporator. This cycle is also known as a vapor compression cycle since a compressor is the main driver of the refrigerant circulation through the four components. In this cycle, there are two energy inputs at the compressor and at the evaporator. The compressor uses electricity and the evaporator draws the heat from the refrigerated space at low pressure. The energy leaves the cycle at the condenser at high pressure to the surrounding medium. So a cooling effect is produced on the evaporator side and a heating is produced on the condenser side. So now we will see how these components and processes are implemented practically in a laboratory unit. A component-wise schematic of the refrigeration unit is shown that contains the four components of the refrigeration cycle along with instrumentation, control switches, and flow meters. Over here you can see a yellowish color closed loop that shows the compressor driven refrigerant circulation through different components. The blue color shows the water path in the condenser and the flow meter since it is used for the cooling of refrigerant. Important points to note are the positions of temperature measurement that are denoted as T1, T2, T3, T4, T5 and T6. Okay, here is the laboratory unit for the refrigeration process. So in this case you can see various components attached on a single board. So for example over here you can see the compressor, which is a piston type compressor and driven by a motor. So that is a complete transparent setup. You can visually see all of the compressor working, and then it is connected to a condenser. So condenser in this case is a water cooled condenser. As you can see, there are two tubes that are going to enter in this condenser. So one tube refers to the refrigeration that is coming into this condenser, and then it is followed by another tube which is actually circulating the water, which is taking all the heat from the refrigerant coming into the condenser. And then this condenser is connected to a coil that is actually a representation of an expansion valve or a throttling device. And over here you can see that there is a flow meter attached to it, so you can clearly control the flow rate of the refrigerant with the help of this flow meter. Then this expansion valve, as you can see, is going into another major component which is known as the evaporator, which is actually responsible for creating all the cooling in this setup. So it actually takes heat from some of the artificially connected heaters, which actually provide some input in the form of the heat to the evaporator, and then the vapors are created in the refrigerant. So then this refrigerant, after going through the evaporator, is then passed to the compressor, and in this way the entire cycle is completed. For the purpose of measurement, there are various panels attached to this unit. So as you can see, there is a voltmeter, there is an ammeter, and similarly there is a condenser pressure displayed, as well as the evaporator pressure can also be observed. The RPM of the compressor can also be seen on the digital tachometer. And then at various locations you can see the temperature value in this digital display. So for example over here there is a selector switch with the help of which you can actually see the temperature at different positions. So for example over here at present it is showing a number 1. So number 1 position refers to the
according to the diagram over here, is the inlet of the compressor. So this is basically showing a temperature of minus 14.6 at the inlet of the compressor. But if you switch to another position with this switch, then it is actually the exit of the compressor, where you can see the temperature of 35.6. Similarly, you can also move it to position number 3, 4, 5 and 6. And so for example, at present it is at position number 5, which is actually the temperature of the water that is going into this condenser. So that is the T5 over here. So when you are taking any measurements of the temperature, so with the help of this diagram that is attached to this unit is very helpful. So basically there are mainly 6 points at which you can determine the temperature, and these temperature measurements are really helpful in determining the overall performance of the refrigeration unit. Another experiment purpose is to control this pressure of the condenser. So this control of the pressure of the condenser can be done with the help of this water flow rate. So for example, over here there is a spindle attached to this water flow rate. So what you can do, you can rotate it. So for example, going towards the left side, so it will actually lowers the pressure. So what will lowers the flow rate. So what will happen, this needle will be moving towards the higher pressure side. And for example, if you have to set a higher pressure than 800 kilopascal, then you can rotate it on the left side. So this is the maximum flow rate over here. So now if you want to lower it, so you can also move to the other side. So and eventually you can see the movement in the needle, and from here you can set the condenser pressure to a fixed value. So all the experiments that you need to perform must be conducted at a constant condenser pressure. The other mode is the evaporator pressure. So that can also be set with the help of this evaporator pressure gauge, and you can maintain this pressure again with the help of controlling this water flow rate. But for that purpose you have to switch the mode of operation, and that can be done with the help of some electronics in some other experiment. Another experiment or the variation that you can make in this entire experiment is with the help of the type of the input that you can make. So for that case, for example, if you are going to vary the evaporator side input or the energy input that is you are giving to the evaporator side, so you must use this switch. So if this switch is pushed downwards or in the down mode, it is actually will be showing some input in the form of this product of volt and the amperes, and this is equivalent to the amount of heat that is being supplied by the heater into the evaporator. But if it is switched in the upward modes, then it is actually showing the motor input that is being supplied to the compressor. So in this case, the energy that you are using for the compressor working, so you can calculate it by using a product of the readings available on the voltmeter and the ammeter. But so all the experiments that you need to perform is basically by varying the evaporator side input. So in that case, what you can do, you can vary the input to the evaporator by using this wheel that actually controls the number of volts. So as you can see, if I am rotating it towards the clockwise direction, then you can set it to some fixed value of, let's say we are going to set it for the 150 volts. So in that case, now this is the amount of power that actually you are supplying in the form of the heat to the evaporator, which is actually being used as a refrigeration effect that is being produced. Another measurement that you might need to take into account is the amount of force being applied on the compressor. So for this purpose, there is a spring-loaded piston, spring-loaded spindle that has been attached over here. So now, if you want to measure how much force you need to apply or being applied onto the compressor, so in that case, you actually need to move this spindle. So for example, in this case, you need to move this spindle upwards, and in that case you have to actually focus towards an arrow that is being shown over here. So this arrow should be in a line with the mark of the lever that is attached over here. So once it is in line with the mark, so then you can tighten up this spindle, and now you can read the amount of force being applied using the scale given on this spring balance. So this is how this entire experiment can be performed by varying certain number of parameters. So for example, you can vary the input control, you can also vary the pressure on the condenser side, as well as you can also measure how much force is actually being applied on the compressor.